Okay, so what is now polarized light? To have polarized light, all the electric fields, they should be in one direction only. So see, for example, this is first wave. Okay, the electric fields are in this direction, the yellow arrows. Here they are in the same direction. Okay, so here also they are in the same direction. Okay, so to say that our light is polarized, all the electric fields should be aligned, they should be in the same direction. So for sure the magnetic fields will follow them, because magnetic fields are perpendicular to electric fields. Okay, so how to represent a polarized light? We represent it like this, only one arrow. What do we mean by this? We mean that all the electric fields are like parallel to each other. Okay, so this is the real representation. Okay, but to make it simpler, we just make it like this. Okay, so light waves with aligned electric fields are linearly polarized. Light is polarized when the all of electromagnetic waves are transmitted at one angle in the same direction. We say alignment of electromagnetic waves. The vibrations of electric fields in each of the waves are parallel to each other. This is, if you want, you can take this definition. Okay, so now how to polarize the light? We said the light coming from the sources is unpolarized for sure. How to polarize it? It can be polarized in two ways. This way, first way, transmission, we will do it the to polarize light, but the second way, it's just natural ways. You will see, we will talk about these later. So we will have like natural ways such as reflection and light scattered by air molecules. These natural ways, they polarize the light. Okay, but the first one, it's the way made by human in order to polarize the light. Okay, so here in this way, which is a transmission, we will use a like polarizing filter. Okay, for sure you heard about it before. Polarizing filter, we use it to polarize light. We use it to make all the electric fields that comes into our eyes in one direction. Okay, polarized light again refers to light in which all waves have electric fields oscillating or vibrating in one plane, in one direction. Okay, imagine here trying to pass a large piece of sheet metal through the bars of jail cell. To do this, you would have to orient the sheet vertically or nearly so. Otherwise, the bars would block the sheet. So see, for example, if you want to pass a large sheet of metal, you can't pass it in any way you want. You have to make it vertical, you have to make it parallel to these bars and pass it, right or no? Okay, so this is very similar. These here bars are very similar to what we mean by polarizing filter. Okay, you will see that we will use polarizing filter. Okay, for light, the light will pass through this polarizing filter. When it passes through this polarizing filter, only the light that is parallel to the transmission axis of the polarizing filter will pass. Okay, so the bars are analogous to polarizing filter, and the sheet is analogous to the plane in which electric field is oscillating. A polarizing filter, what is the polarizing filter that we will use in real life? Is actually made of transparent crystal with long molecules. Okay, the arrangement of these molecules or the arrangement of these atoms, okay, it's what allow the electromagnetic waves to pass. Okay, so it depends on the arrangement of of atoms or molecules. You will see, like for example here, this is an unpolarized light that is going to pass through a polarizer. Okay, polarizer. This is a polarizing filter. See, here you have this transmitting axis. The transmitting axis will be given, so it means here all the molecules or the atoms in this material, in this crystal, are arranged like this vertically, so they allow only the light which is vertically, okay, which is vertical, to pass. All other lights, all other directions are absorbed by this material. Okay, so this is unpolarized light coming from the sun, for example, and we are using here a polarizing filter. Again, the polarizing filter is made of, it's like material, it's like transparent crystal, okay, in which the molecules, they are arranging themselves in a specific way, okay, in a specific way. So the light, the direction of electric field that is parallel to this arrangement will only pass. So see here, only the one which is parallel to this, it passes. All the others, the one which is like this, the one which is like this, all the other directions are absorbed by it. So only the light that is what parallel in this direction passes. Okay, in case here we use another polarizing filter, okay, another polarizing filter, it means another material, another crystal, in which here the transmission axis, it is horizontal. What means the transmission axis horizontal? It means here that the molecules or the atoms are arranging themselves like this. Okay, so we just look at the transmission axis. Transmission axis is horizontal. Okay, so look here. Now your polarized light, is it horizontal? It's not, it's vertical. So this polarized light now, it can't pass through the second polarizing filter because it's not parallel to this transmission axis. So this polarized light will be absorbed and no light will pass. Here, if we want, so what conclusion can we conclude, girls? We conclude that if we want to block totally the light, what do we use? We use two polarizing filters that are perpendicular to each other. See, this is the first one and this is the second. Okay, the first one, it has this specific transmission axis. Okay, so only the electric fields that are parallel to this can pass. Only. So now what's called this light? This light now, it's called polarized light. Okay, because all the electric fields we have now, they are parallel to each other. Okay, right. The second, if we use a second polarizing filter, so second polarizer in which the transmission axis is horizontal. Transmission axis horizontal, it means here no light can pass at all. Okay, because the polarized light we have is vertical, so no light can pass at all. This is another example. This you have it in your book. This is an unpolarized light coming from the source of light, like sun, for example, and it passes through the first polarizer. What is polarizer? So polarizer is like a transparent crystal in which the molecules or atoms, they have a specific arrangement. So the arrangement of molecules made what's known as transmission axis. Okay, so the transmission axis will be given. The transmission axis here, as you can see, is vertical. So all the directions of electric fields will be absorbed except what? The vertical, it can pass. Except the vertical one, it can pass. So girls, it's like picket fence. So it's like the bars, the example of bars I gave. In order to let the metal sheet pass, you have to make it parallel to the bars. You have to orient it parallel and you can pass it through them. But if the metal sheet is horizontal, it can't. How can you pass it to the other side? You can't. Okay, so here a very similar concept. All the electric fields in all the directions will be absorbed except the one which is parallel. So here we get polarized light. Since our electric fields are parallel to each other, what do we call this light? Polarized. So any light that passes through through polarizer, now it's polarized. Okay, here if I use a second polarizer, see the transmission axis here, it's not like vertical, it's oblique. So here it's tilted. So girls, here some light will pass. Okay, some light will pass, but for sure it will be less intense. It will not be bright as this one, right or no? Okay, because part of this polarized light passes. Okay, it depends on the angle, so the first, I will just show you the first transmission axis. Here it was like this, right? So this is the first transmission axis. Now the second transmission axis, we have angle theta between the first transmission axis and the second. Okay, so the greater this theta, like the greater this angle between the first transmission axis and the second, the less light will be able to pass. Okay, and if this transmission axis here, if this one is perpendicular to the first, okay, so no light will pass at all, because if this perpendicular, so these light will be blocked, will be absorbed. They will not be able to pass through the second. So here put a conclusion. Always when you have crossed polarizers, what means crossed polarizers? Their transmission axes are what? Are perpendicular. Always when you have like crossed polarizers, two polarizers that have transmission axis perpendicular to each other, in this case you will block totally the light. Okay, so polarizing filters only allow light with electric field aligned with the transmission axis to pass through. Okay, so again, transmission. Okay, this we are talking about the first way in order to polarize light. So at the beginning, light vibrates in all directions. In order to polarize this light, we will use polarizing filter. So polarizing filter, it acts like picket fence. It only lets certain direction vibrations pass through it. Okay, only the electric fields that are parallel to the transmission axis can pass. Therefore, if you pass light through two polarizers, you can completely block the light from passing through. How? So how should you place the two polarizers in order to block the light totally? We should place them how? Perpendicular to each other. So again, the same thing. Here you have unpolarized light. This is the first polarizer. See, the transmission axis is vertical, so only this one can pass. Only this one can pass. The others are what? Blocked. Okay, so this one can pass only. Now we got polarized light, linearly polarized light. If I use second polarizer with its transmission axis perpendicular to the first, okay, this transmission axis perpendicular to the first, so here, can you pass this light through this material? We can't pass it to the other side. Okay, so the light here will be absorbed by this material and no light passes to the other side. So light here is totally blocked. So in order to block the light, if we want to block it, we use two polarizers with their transmission axes perpendicular to each other. Okay, so this means that if initially unpolarized light passes through crossed, what means crossed polarizers? Their transmission axes are perpendicular. No light will get through the second one. Okay, you have also this example in your book. Here you have two filters. These two filters are just parallel to each other. Okay, so the light coming will pass through the first one, will be polarized, but since here the transmission axis is parallel to this one, the polarized light will pass normally. Okay, but here, see, for example, here the light will pass through the first one. Okay, the light will pass through the first one. It will be polarized. The second one here it has a transmission axis which is perpendicular to the first polarizer. So the polarized light from the first will be blocked. It can't pass through the second. Hope that it's clear. You have to repeat it for sure many times to get the concept. Okay. Now we will talk about naturally polarized light. Okay. The light, girls, in our everyday life, we can have a partially polarized light even without using any polarizer. How? This can be happened, girls, by reflection. We know that unpolarized light coming from the source, from the sun, is going to hit surfaces like water, like glass. These shiny surfaces, okay, these shiny surfaces, this is the unpolarized light. When it comes and it hits this shiny surface, for sure you know that some of light can pass through, can enter the water or the glass, and some can be what? Reflected. Okay, so the reflected light now is polarized. Okay, it's partially polarized, and its polarization occurs how? Parallel to the surface it reflected off. So light reflected off a shiny smooth surface of transparent material such as water or glass is polarized by the reflective process. Then, which way should the transmission axis be oriented to block the glare light? Okay, and why do fishermen like polarized sunglasses? Let's think about these two questions. Take your time to read them again, to read the process, and then I will record the other video. Okay, so we have reflection. This unpolarized light coming from sun hits the shiny surface. Some of it reflect and some goes inside the water or inside the glass. Other words, it refracts. In other words, okay, so we are focusing about reflected light. The reflected light, it's going to your eyes, and here we can use polarizer. We can use the transmission process. What means transmission process? Transmission, it means by using polarizing filters. Okay, if I want to block the light here totally, I can use polarizer. Which way should the transmission axis of the polarizer be oriented to block the glare light, the light which is reflected? Okay, and why do fishermen like polarized sunglasses?